In this lesson, we'll begin defining the interface for the object that we'll use to interact with the iTunes Store Search API. Our controllers will need to interact with the data returned from our calls to the Search API, but we really don't want to code up this direct interaction in the controller itself. Doing so would be a poor separation of concerns and would unnecessarily couple our controllers to the implementation details of this interaction. Instead, this is a concern that we should really move to our model tier. When I say model tier, I don't necessarily mean our model objects, i.e. our entity classes, artist, and album. Directly embedding some web service interaction code in these objects would typically be an unnecessary coupling as well. We could conceivably provide methods on our entity classes that indirectly perform the web service interaction, but arguing the pros and cons of what would be the right OO design for our app would really require a standalone class of its own. Instead, to keep a nice separation of concerns and keep things simple, we'll create an object called Music Store Service. Let's begin by creating a new NSObject extension called Music Store Service under a new group called Services. I'll right-click and select New Group. And with that selected, I'll type Command N. Let's call this Music Store Service. And we'll have this extend from NSObject. This object will need to have three responsibilities. Find a list of artists matching the search term we enter into our UI search bar component. 2, look up a list of albums for the artist we select in our search results list. And then finally, when we view the album details via our search UI, we want to retrieve the album artwork so the user can view the details in all their spectacular glory. Since I know I'll be referencing the artist and album classes in here, I'll begin by providing references to our artist and album class. And then I'll add a new method in here, let me shrink down the left-hand side, called Find Artist by Artist Name Completion Block. Now the first argument is the artist name, so this will represent what the user's typed into the search bar component. But what about this thing called a completion block and its odd-looking syntax? Well, this will be a block argument. We've seen blocks a few times in this course, but let me provide you a little more detail about them. Blocks were first introduced in iOS 4, and blocks are what other languages like Ruby and JavaScript call closures. At the most basic level, a block is an inline function that can be used whenever some callback operation is performed. This fits perfectly when you're performing some long-running operation, such as interacting with a web service. As we don't know how long this operation will take to complete, we don't want to perform it synchronously, meaning that we'll block our UI until the operation completes, as doing so would provide a terrible user experience. Instead, we want to do this in an asynchronous manner. By using blocks, we can queue up this call in a background operation, and when it completes, it can invoke the completion block to perform whatever tasks are defined. If that was all the blocks could do, they would still be pretty cool, but blocks can also capture data from their enclosing scope, such as local variables declared in a method, or even instance variables of the enclosing class. Even if the enclosing context goes out of scope, such as the variables defined in the local method stack frame, the block still has access to that data. Granted, this is where the details of blocks get to be a bit more complex, but the power this capability provides is extremely useful in many scenarios. So back to the task at hand, which is defining our completion block argument. As you can see, the syntax for defining this block is pretty ugly and frankly not very readable in my opinion. When defining my own blocks, I like to use a C language feature called a typedef. And a typedef allows me to define a new type for my block so that methods using the block can refer to it via its typedef. So prior to the interface declaration, I will define a typedef. So void is the return type for this block. This is the name of the block. And here are its arguments. We'll take an ID result and an NS error indicating if any errors happened while processing this request. With this defined, I can go and delete the contents of my completion block and replace it with my service completion block. So certainly I think that reads much nicer. The next method we want to define is one to retrieve our albums, and we'll call this load albums for artist completion block. So once again, we can reuse that typedef. And finally, we'll define a fetch artwork for album completion block method. This will allow us to go and retrieve the album artwork when the user views the details. Let me switch over to my implementation file. I'll add the imports. and provide a stub for my find artist by artist name. Same thing for my load albums for artists. And then finally my fetch artwork for album. We've created our music store service and have defined its interface. In this lesson, I've also provided you with some additional details about blocks, and I think you'll find them to be a great complement to any type of asynchronous programming that you do on the iOS platform. I'll see you in the next lesson, and we'll start implementing the methods in our music store service.